This video is going to work out some homework examples from homework 7 that is called Applications of Radical Equations. So the first problem that you will see will be something like a steeplejack can see 14 kilometers to the horizon from the top of a building. These numbers are related by the equation V equals 3.5 times the square root of h, where V is the distance in kilometers from the steeplejack's eyes to the horizon, and h is the height in meters of the steeplejack's eyes. What is the altitude to the nearest meter of the steeplejack's eyes? Well, first of all, I did not know what a steeplejack was, so I looked it up on Google, and it is a person that goes up on like the roofs and works on like steeples of a church or chimneys or something like that. So I'm going to take my equation, which is V equals 3.5 times the square root of h. And I got a number of 14 kilometers. And that is the only other information I got. So I have to figure out where that 14 kilometers goes. And right here, h is the height in meters of the steeplejack's eyes. So we don't know the height of his eyes. So the 14 will go in for V. And then from homework 6, we learned that to solve a radical equation that we need to get the radical by itself. So the opposite of times 3.5 would be divide by 3.5. So I'm going to do that on both sides of the equal sign. And when I do that, I have square root of h on one side of the equal sign. And then I take my calculator, and 14 divided by 3.5 is 4. And I'm not quite finished because my h is still under a square root, still under a radical. So to get rid of a square root, I square it or raise it to the second power. I have to do that on both sides of the equal sign. So when I do that, the square root or radical goes away. So h equals, and then I've got 4 times 4 gives me 16. And it's not 4 times 2, but 4 times 4. In problem number 2, we're given the formula V equals the square root of 2gh. This formula gives the velocity v in feet per seconds of an object when it falls h feet per second, accelerated by the gravity g in feet per second squared. If g is approximately 32 feet, find how far the object has fallen if its velocity is 160 feet. So again, I write my formula, V equals square root of 2gh, and then I'm going to start substituting things in. So they did give me a value for V. They told me the velocity is 160. So I'm going to substitute in 160, square root 2, and then gravity, if g is approximately 32 feet, so they did give me a value of g. And what they want to know is the height. So then I'm going to simplify this. And I'm going to go ahead and simplify underneath the radical. So the 2 times 32 is 64. And to solve the radical equation, I need to isolate the radical, which it's isolated. And then, because this is a square root of 64h, I'm going to square this side of the equal sign and also square this side of the equal sign. So when you square a square root, you get rid of the radical. And then you find out what 160 squared is. And it is 25,600. And then to solve for just the h, divide by 64 on both sides of the equal sign. And so I get h equals, and then I will do my 25,600 divided by 64. And oops, my answer is 400. So number 3, the radius of some planet is 3,000 miles. And that goes with radius. Use the formula for the radius of a sphere given its surface area A to find the surface area of the planet. And we're going to round to the nearest whole number. So my formula is already written here. The radius I am given. So I'm going to put 3,000 in for the R. Square root. I am not given the area. And on bottom, that is supposed to say 4 pi. Again, I have my radical isolated. And since it is a square root, I'm going to square both sides of the equal sign. So I'm going to do 3,000 squared. And that is 9 million. And then this square gets rid of that square root. So now I have A over 4 pi. And to get rid of this fraction, we're going to do what we've done many times before. We're going to multiply times what's on the bottom of this fraction. So multiply by 4 pi on both sides of the equal sign. And so you can put all of that in the calculator. And if you already have your answer here still in the calculator, then just multiply it times 4 pi. And it will be a large number. And on this side, that 4 pi and that 4 pi go away, which leaves me with the area. And the directions did say round to the nearest whole number. So the answer that I would put in my final answer blank or in Math Excel is going to be 113, 097, 356, because this 5 makes me round that up. Problem number 4. In psychology, it has been suggested that the number S of nonsense syllables that a person can repeat consecutively depends on his or her IQ score, I, according to the equation S equals 2 square root of I minus 9. Use this relationship to estimate the IQ of a person who can repeat 13 nonsense syllables consecutively. So my formula was S equals 2 square root of I minus 9. I am going to substitute in 13, and it goes in for the S. So 13 goes here. In order to solve this, my radical has to be isolated. So I'm going to add 9 to both sides of the equal sign. And then my radical is still not isolated. So I'm going to divide by 2. And now my radical is isolated, but I still have the radical. So I need to, since it is a square root, square both sides of the equal sign. So 11 times 11, 121 equals, and then the square to, when we squared the square root, we get rid of the radical. So I is 121. Number 5 has a couple parts. The first part, before determining the dosage of a drug to give a patient, doctors will sometimes calculate the patient's body surface area, BSA. One way to determine a person's BSA is to use the following formula. BSA equals the square root of W times H over 3,600. And the W is their weight, and the H is their height. So in part A, calculate the BSA of a patient who is 180 pounds and 180 centimeters tall, which is about 5'9". And your answer will be a fraction. So the BSA equals, the weight was 180 times the height was 180 over 3,600. And all of that can go into the calculator. So this example actually did not turn out as a fraction. It was 3, but you could have possible answers of, like, you could have 9 over 2. You could have 10 over 3. You could have 12 over 5. You might even have a like a 14 over 11. Any of those are possibilities. It just depends on what numbers you were given to work with in your problem. All right, B, the second part of the problem. Suppose the nurse forgot to measure the height of the patient. How could the nurse calculate the height of a patient with a BSA of 2 square root of 2 square meters and a weight of 171 pounds? So again, we're going to use the formula we were given. BSA equals square root of weight times height over 3,600. This time we're given the BSA. So 2 square root of 2 equals square root, and the weight is 171. I don't know the height, so I'm going to put H over 3,600. So the radical is isolated, even though it's kind of ugly. So we are ready to square both sides of the equal sign. And so over on this side, this actually means 2 square root of 2 times 2 square root of 2. And then we squared a square root, so the square root sign is now gone. So this is just 171h over 3,600. And I ran out of room, so I'm going to have to go up here. So 2 square root of 2 times 2 square root of 2, what we're doing is taking them times each other. So the big 2 times the big 2, that gives me 4. And then the square root of 2 times the square root of 2 would be the square root of 4, which the square root of 4 we know is 2. So this is the same thing as 4 times 2. So there's my 8. Over here, I still had the 171h over 3,600. And so I'm just going to bring that down right here. 171h. Now to get rid of the 3,600, I need to multiply times the 3,600 on both sides of the equal sign. And so that gives me 28,000. Let me change colors. 28,880. And this 3,600 and that 3,600 cancel. So 171h. And now I'm ready to divide by 171. So the height then would be taking that 28,800 divided by 171. And we're going to give an approximate here of 168 centimeters. Okay, number 6, we're going to be using the written information as well as that graph. When firefighters are working to put out a fire, the rate at which they spray water on the fire depends on the nozzle pressure. The formula F equals 110 times the square root of P models the water's flow rate F in gallons per minute in pounds P per square inch. To achieve a water flow of 600 gallons per minute, 30 pounds per square inch nozzle pressure is needed. This can be shown on the graph by the point, so I'm just going to find that point. The 660 gallons would be the information on this axis. And then the pounds per square inch would be this one. So I would be looking for the point 30,600. And numbers 7, 8, 9, and 10 are a review of the ones that were like homework 6. So on number 7, my radical is isolated. And since it's a square root, I'm ready to square both sides of the equal sign. When I square a square root, the radical sign goes away. And I need to make sure I'm doing 6 times 6. And then I'm solving for x. We cannot have a variable with a negative number, so I need to make sure that I am dividing by -1. And then the check is taking that original equation, and I'm going to plug in this -26. So 10 minus, and then the x was -26. So this is really 10 plus 26. And the square root of 36 is in fact 6. So because that checked out, then -26 is the correct answer. Number 6, mine is to the 6th root, but both radicals are isolated. So I am going to raise each side of the equal sign to the 6th power. And when I do that, the radical sign goes away, and I am just left with what's under each of those radicals. And then I solve for x. And mine is going to end up as a fraction. I do not believe that yours does. I think yours ends up as an integer. So on number 9, I have x equals square root of 3x minus 12, and the plus 4 is not under the radical. So I need to get rid of it because I need my radical to be isolated. So I'm going to do minus 4 on both sides of the equal sign. So this gives me x minus 4 equals square root of 3x minus 12. Now that the radical is isolated and it is a square root, I'm going to square both sides of the equal sign. And remember, on this left side, this is really x minus 4 times x minus 4. And then we get rid of the radical. So you have to FOIL on this side. So x squared minus 4x minus 4x plus 16. And then I need to simplify on this left side. And whenever we have a squared term, we need to make sure that we get it equal to 0. So I'm going to subtract 3x on both sides of the equal sign, as well as add 12 on both sides of the equal sign. And so I end up with x squared minus 11x plus 28 equals 0. And I will either have to split the middle or do quadratic formula. And since I ran out of the room, I will need to finish it up here. So I'm going to factor. So I know that -7 plus -4 give me this -11. But -7 times -4 gives me this +28. So then now I'm just going to set each of these equal to 0. And then solve for x. So my answers are 4 and 7. And then the last problem, I do have the radical isolated over here. So I can square both sides of the equal sign. So when I square a square root, the square root sign goes away, but everything else underneath it stays. And then this is the same as x minus 3 times x minus 3. So I need to simplify that side. So this will be x squared minus 3x minus 3x plus 9. And I'll keep simplifying. So I have two x squareds and I need them on the same side of the equal sign. So if I do minus x squared, ooh, I kind of like that because those cancel and then I don't have to worry about splitting the middle or quadratic formula. But I do have to keep solving for x. And so I'm going to have to rewrite that up here. Okay, so I'm going to subtract 9 on both sides of the equal sign. So -18 equals -6x. And then my final step, to divide by the number in front of the x. So my answer will be 3.